In this video, we are going to take a look at the outer join and then the cross join. And we are going to start with the left outer join. We can see that we have left specified. We have to provide one of these keywords to indicate what type of outer join we're doing. Then we have the optional outer. We're going to enter this on all of our queries this week. Later on, if you want to remove that, you can. But right now, we're going to start with left outer join, and then we're essentially going to join those tables on a join condition. If we go back to our diagrams, before, when we were looking at our diagram, it was essentially we had a circle that was not filled in, except in the middle for the two tables that we were selecting from, doing that intersection of where we had things that met that condition. This time we're specifying we want everything in the left table, regardless of whether there's a match with what's on the right table. But when there is a match between the two tables, then we'll fill out the data in the left table to include those fields that exist in the right table. So we're going to essentially be bringing in everything from the left table and then filling in fields from the right table when we are doing a left outer join. Let's go ahead and take a look. We're going to be using AdventureWorks for this. And we have a couple tables that are perfect for this type of activity. And those are going to be the Human Resources Job Candidate and the Human Resources Employee tables. Let's look at what's in our Job Candidate table. We can do a select asterisk from Human Resources dot Job Candidate. When we execute this query, we have several rows here that are returning either a value for that business entity or null. Let's take a look at our employee table. Select asterisk from Human Resources dot employee. If we execute that, we have a similar business entity ID. Our initial thought would be that we should join on that business entity ID between the two tables, but we can't always make that assumption. In this case, it's probably a good assumption, but not everything as we go through and look at all the different tables can potentially follow that same course. Let's double check. Let's create a new database diagram. We're going to bring in our job candidate and our employee to make sure. So these are going to be employee followed by our job candidate. Add those two tables. If I click on the relationship between the two and expand the properties for the table and column specification, it is indeed on that business entity. But we should never just assume that it's going to be on that, because there are some gotchas within the AdventureWorks with that business entity ID. If we go back to our AdventureWorks query window, the first thing that we want to do is we want to go ahead and do an inner join. Let's take a look if we happen to join two of them together and get that intersection where we have that join condition where everything in both tables has to match to see how many records actually exist between the job candidate and then the employee table. So we're going to do a select asterisk from Human Resources dot Job Candidate. We'll call this C, inner join, Human Resources dot Employee. We'll call this E, and this is going to be on C.Business Entity ID. Business Entity ID is equal to E.Business Entity ID. And if we execute this query, this is going to indicate that I just have two rows. that are going to be returned. So I have a match of 2 rows between the 2 different tables. Now, if I look at my job candidate, I have a total of 13 rows in that table. If I'm doing a left join, and we think of our tables, we have job candidate. If I was putting them right next to each other, I would have human resources job candidate, then I would have human resources employee. So the job candidate would be considered the left table. The employee would be considered the right table. So if I change my inner to a left outer join on my human resources employee table and execute this query, I should see the same 13 rows being returned, but then when I have data from the human resources employee table that matches, it should fill out the row. If I don't have a match, then it's essentially going to set it to the default values, which is generally null. So let's execute that. Let's see. We have a lot of records now being returned where we have null because there wasn't a match in the employee table. Therefore, it didn't bring in the data, but we got everything from the left table, which is our job candidate table. And where we did have a match, it brought in the data from the right table. So that's kind of the way that a join, when we're doing the outer, actually works for the left outer join. So if we go back to our slide, we also have the ability to do the right outer join, and this time it's going to take everything from the right table and then fill out all the fields that exist where there is an intersection between the left table and the right table. Similar to what we did before, but it's just going to be swapped. So let's go ahead and let's go back. And in this case, we're changing it to a right. We're not going to execute it yet. We want to find out how many rows we have in our employees table because we should have the same number of rows returned. And we can see down here in the bottom that we should have 290 rows returned. So when we execute our right outer join, we would expect that we have 290 rows returned. So if I do this, it's going to, in fact, return 290. And if I look, most of the first initial set have nothing as far as the information that's being returned from the job candidate. We only have 2 rows that match, so we may have to scroll for a while until we see populated data in the job candidate. There we have one of them. So there's another one in here somewhere. If we continue to scroll down, there's the second one. So those are the only 2 in the job candidate table that actually match the information in the employee table. So that data is filled in. Everything else is null for those rows, but we get everything from that employee table being returned to us in that result set. Now, if we go back to our full outer join, that means that I'm going to get everything that's in the left table, everything that's in the right table, and only when there is a match between the join condition will I have data filled out for both of those table instances. So let's go back and let's change this from a right outer join to a full outer join. Now, if we think about it, we had 13 rows in the one table, but we had 2 that matched, so that was only 11 unique rows. So if we have 11 rows in the one table and we had 290 rows in the other table, because we're going to assume that that 290 counts for those 2 records in the job candidate table, we should have a total of 290 plus 11 unique rows from the job candidate being returned. So we should get 301 rows if we're doing a full outer join. So let's go ahead and execute our full outer join. And we can see initially we're bringing in all of our job candidate fields that do not have a match because we are missing record 4 here. And if we come down, we're also missing 8. If we scroll down here, we should again see that we have those records where we have a match between the 2 tables. and we can continue looking at this stuff, but look down here, 301 rows returned. So that is going to be our full outer join. Now, if we go to the next, this is going to be where we do a cross join. And this is something that you should very, very carefully think about before you try to implement something like this. What's going to happen is it's going to end up with a Cartesian product. So essentially what's going to happen is for every row in the first table, it's going to match to every row in the second table. So if I have 13 rows in the first table and I have 290 rows in the second table, when it actually joins, it's going to be the product of 13 times 290 that's returned to us. For our AdventureWorks table, the one that we're currently using, maybe that's not so bad, but if we were using larger tables, the performance could get pretty atrocious when it's trying to match each row. So the first row to the first row, the first row to the second row of the second table, first row to the third row of the second table, and on and on and on. Then it would do the second row to the first row to the second row to the third row, etc., etc. So that's how it's actually going to work. So we're going to go ahead and we're going to change our join to be a cross join and remove the condition. And this is going to essentially be where we're changing this to a cross join. Removing our on condition. And if we execute it, we have 3,770 rows. If we do 290 times 13, that is 3,770 rows. That is our cross join. The other way that we can do that using the old style is similar. We have our select asterisk from our tables, and this is going to be our human resources job candidate C, comma, human resources employee E. When we execute this query, not having any where conditions whatsoever, I can get the same result. Notice 3,770. So this is where we're going to end this video. We'll cover the Oracle in a separate video, and then we'll also have a video on union statements as well.